Good afternoon, everyone. Myself, Dr. Husana Johar RV, Assistant Professor in the Department of CSE AML. Today, I'll be going to give a introduction to the Artificial Intelligence Laboratory. Just have a look. So the program is implement A star search algorithm. What exactly the A star search algorithm is? It is reaching a destination via the shortest route. It is a daily activity well to do. Especially this algorithm, it is used to find the shortest path between the source and the destination node. So in the mathematical optimization and the computer science, heuristic is a technique in order to solve the problem and more quickly when the classical methods are too slow or finding an approximate solution when classical methods fail to find any exact solution. This is how it can be achieved. It can be achieved by the shortest method, maintaining the accuracy and the precision for the speed. The heuristic function here, it is being used in order to find the cost function, which is being implemented in the search algorithm. So A-star achieve optimality and completeness, two valuable property of search algorithms. When a search algorithm has a property of optimality in the sense that guaranteed service, where it can find the best possible solution out of the so many searches it has been followed within the network. So when a search algorithm has the property of completeness, it meant that if a solution to a given problem exists, the algorithm is say that guaranteed. That means if you find the optimal solution for the given problem, we can say that it is a guaranteed service. So now understand how exactly the A starts work. First, it begins with the node that we call it as the starting source node, and in order to reach the destination node. Here, what are the steps or the following things will be followed out. The transition, it acts like moving between the states of the nodes. It in the starting node where start searching, goal node it is target to stop searching, and the subspace where the collection of nodes like all board position of the board game. Cost, which is the as I mentioned that we are finding the cost function between the actual and the estimated cost in order to build a model in such a way that the cost has been reduced. Here, the cost functions are illustrated by the G of n and the H of n. The G of n represent the exact cost of the path from the starting node to the any node in the network, and H of n represent the heuristic estimated cost from node n to the goal node, and F of n is the lowest cost in that neighboring node. Each time A star enters a node, it calculates the cost f of n, that is the n being the neighboring node to the travel to all the neighboring nodes, and then enter the node with the lowest value of f of n. So finally, we calculate the f of n actual, the lowest cost of this node. We can calculate this, it is sum of the actual and the estimated node as it is mentioned, g of n plus h of n. So here we are taking one example of a maze problem. As you can see here, left side of the maze problem at the right position of every node of the maze. Here, what exactly we are trying to find out that in this particular problem, there are 4 moves from left, right, up and down from a maze position provided a valid step is available. In the red square position, no movement is allowed. Like in state position, only down position is available since up and left move are blocked by the wall, while the right is red square position, thus no movement is allowed. First, we will create a below class and helping a function, the class node that can be used to create an object for every node with the information as the parent node and the current position in the maze and the cost values of G, H and F. We need to define the path function that will return the path from start to the end node that is start. We will establish search function which will be drive the code logic, initialize all the variable first part and then add the starting node to the yet to visit list. Define a stop condition to avoid the infinite loop. Define movement in terms of relative position. Repeat the following step until the criteria have been met. Look for the lowest f cost square on the yet to visit list. This square becomes the current square. We'll also check max iteration reached or not. Check if the current square is the same as target square, meaning that we have found the path. Further, use the current square and check 4 square adjacent to this current square to update the children node. If it is not movable or if it is not the visited date, ignore it. Otherwise, create a new node with the parent as the current node and update the position of the node. Check all the child node created to see if it is not yet to visit the node. Add it to the yet to visit node. Make the current square of the parent of the square record the FG and the H cost of the square. If it is the yet to visit list already, check to see if this part to square is better using G cost as the measure. A lower G cost means that this is a better path. If so, change the parent of the square to the current square and recalculate the G and F squares of the square. The main program will define the maze start and end position. Then we will use search function, and if the path exists, we can print the path from the path function. Let's go through the code step by step about the step mentioned above. First, we will create a class for a node that will contain all the attributes associated with the node, like parent of the node, position of the node, and all the three cost GHFN for the node. We initialize the node and build a method for checking the equality of the node with another node. Here is a loop where we have been created with the parent node have been assigned with some position GHFI. That is what this particular code part of the thing. As you can see, self G equal to 0, self H is equal to 0, self F is equal to 0. This is where we are going to initializing the node functions as 0. Next, we will build a path function which will be used to return the path from the start to the target node. This is the code for this in order to build the path function. Next, we will define self function which has multiple steps. The first step is to initialize the node and the list that we will use the function. In this particular code, as you can see, the steps are as follows. First, we'll initialize the start node, then the end node. After that, a list of node yet to be visit has been initialized, and the list of node visited so far has been initialized through these nodes. Add the starting node to the yet to visit list. Define a start condition to avoid an infinite loop. Define the moment in terms of relative position, which will be used to find the child node and other relative position. As you can see, this is an example where we are illustrating the same example of the maze. Now we use the current node by comparing all of F cost and selecting the lower cost node for further expansion. We also check max iteration reached or not, set a message and stop execution within this code. Remove the selected node from yet to visit and add this to the node visited list. Now we put a check if it could find the target square. If we are located the target square, then call the path function and return. This is what has been illustrated in this particular script. For the selected node, find out all the children, get the current position for the selected node, and check if a valid location exists. If any node position is invalid, then ignore that and add to valid children node list for the selected parent. Here in the diagram, we show that black circle node is the current node and the green circle nodes are the correct children node. This is what we can see, what we have just now declared. So correct node and the bad nodes. For all child node, if the child is in the visited grid, then ignore it and try the next child node. Calculate the child node GHF values for H heuristic function to reach the goal node for the current node is calculated using the Euclidean distance. If the child in the yet to visit list, then ignore, else move the child to the yet to visit list. So this is what exactly the formula which is being used to calculate the Euclidean distance to use to calculate the H cost. This is a major activity in real life problem to find the appropriate heuristic search problem. Now finally we will run the program from the main with the maze and obtain the path, refer the path, also show using the arrow. Thus we can see that here exactly you can see that this is the path which we have find out optimality solution using this A star search algorithm. So finally conclusion is that A star is a mighty algorithm in artificial intelligence with a wide range of usage. However, it is only as good as heuristic function which can be highly variable. A star is also popular choice for finding because it is reasonably flexible. It has found application in many software systems, especially machine learning and search optimization to game deployment where characters navigate through complex terrain obstacle to reach the player. So now we'll move on to the simulation part where we are running this code in order to do the implementation part. So as you can see in this code, what just now I have been explained that initially we are going to initializing the node. We are going to initializing the node. We are going to initializing the node. Then further we are going to see that here initialization occur. Finally, and then we are going to initializing the heuristic function and we are checking the same Euclidean distance to find out the distance between the source and the destination node, and finally we are find out the path, and here is the result of that. We can see that which is the best path for this. So as the result itself is illustrating, as you can see, the path found out of this A to F, G, I, J. Out of A to I path, the one best path find out through this A star search algorithm is that the path it is A, F, G, I, J. That is the best path which we have find out through this algorithm. Thank you.